I'm Tim. This PCBSync.
Previously, we've been talking about this. When it comes to impedance reference and return paths, a lot of people have left comments. You get the theory, but how do you actually set it up in KCAD? So today, we're skipping the theory and jumping straight into hands-on practice. We'll start from scratch and build a 4-layer stack-up that's truly suitable for RF design. Why use a 4-layer board? Hold on, don't rush. Let's answer a question from the menu first. Why do so many RF boards prefer 4 layers? Because you can do RF with a 2-layer board, but the margin for error is low, the return path is prone to issues, and the impedance isn't stable. A typical 4-layer board looks like this. First L1, L2 is the ground GND reference plane, L3 is the power reference plane, and L4 is also a signal layer. The most important part here is that L1 is right above and closely coupled to the GND layer. This way, the return path is the shortest and the impedance is easiest to control. Next, let's go into KiCad and see how to set up a 4-layer board. Click here to open the Layer Manager, then select Physical Settings. You'll see that by default it's set to 2 layers. Here, we change it to 4 layers. That's all there is to it. After switching to a 4-layer board, you'll see that it adds N1.cu and N2.cu, and the corresponding dielectric layers for those layers are also added. Here, we can directly enter the parameters. For example, for outline, we set the layer thickness to 1 micron, or 1 ounce, which is 35 microns. Then, for the corresponding L1 dielectric layer, we set the thickness to 0.18. Next is GND, the second layer. The thickness is the same as before. Then, for the dielectric thickness, we'll set it to 1 millimeter here. For the third layer, we'll also change it to 0.18. So why do we set it to 0.18? It's simply because 0.18 is a standard spec supported by many PCB manufacturers. A 50 ohm microstrip is also easier to achieve. In short, this is one of the most common configurations for RF engineers. Next, let's find the dielectric layer. You'll see this FR4 here. Click the little dots next to it, and then you can make changes. We'll start by selecting the default FR4. You can modify its parameters. The first one is the DK, which we talked about earlier. We can change it to 4.3, and the next one is DF, set to 0.018. This part is very important. Many people only change the thickness and forget to adjust the DK, which leads to completely incorrect impedance calculations. The software won't warn you, but in the real world, you'll definitely find out. So click OK to save these parameters. Next, let's see how to calculate the impedance. We can do this using a tool. In the Tools menu, select Calculation Tools. After opening it, choose Transmission Line. Then select Microstrip, because what we're working with here is a microstrip for the calculation. Here we can also make adjustments. Change the ER to 4.3. Then change the thickness to 0.18. Mine is already set to 0.18 by default. Then for the copper thickness, T is also 35 microns, and the target impedance is 50 ohms. When we click Calculate, we can see that W, which is the trace width, changes. This is what we need to use. At this point, we know the trace width. Our trace width isn't just something we came up with off the top of our heads. It's calculated based on the materials. So let's try again and change the FR4 material to Rogers 4350B, which has an ER of 3.48. We'll keep everything else the same, still at 50 ohms. Pay attention to this value, and let's click Calculate. Hey, you'll notice it gets a bit bigger. That's because the trace width is different for different materials. A lot of people copy someone else's PCB and end up choosing the wrong impedance. The reason is right here. Everyone uses different materials. Today, we did four things. First, we built a 4-layer RF stackup. Second, we set the thickness. Third, we entered the DK and DF values. And fourth, we completed the 50-ohm calculation. If you plan to work on ESP32, Bluetooth, Wi-Fi, LoRa, and so on in the future, this stackup will meet the needs of most projects. Ah, thank you all.